Alright, today we're working on a 2014 Freightliner Cascadia with a Detroit engine in it. The driver said the check engine light came on. I went ahead and pulled the codes, and going from automotive to diesel, the code formats are a bit different. There's no P0 or anything like that. They have a lookup code and an FMI code. So the two codes we're looking at right now, SPN 103 FMI 2 and SPN 641 FMI 5. That's going to be turbocharger speed not plausible and turbocharger control circuit failed to open. Alright, so this first code, all that it means is the computer is not happy with how fast the turbo is turning. The data it's reading from the speed sensor, the MCM has determined that it's unplausible. It really doesn't like what it sees. And this other code for the turbocharger control circuit failed to open, all that means is that the computer is determining that there's an open circuit somewhere either in the wiring or in the control actuator itself. Alright, we're going to load test the wiring going from the MCM to the turbocharger speed sensor, and as long as it load tests fine, we're not going to worry about changing the sensor right now. We're only going to worry about the turbocharger actuator itself, because I believe the actuator going out can upset the speed of the turbo and what the computer is reading. And that sensor is around $200 and something from the dealership. So we're gonna pass on that one for now. Unless the code doesn't go away, then we'll see about testing the sensor out. All right, so over here on the passenger side of the engine, we've got the turbo right here. We've got the sensor wire coming out there, and the actuator is actually over here behind the alternators. That's where we're gonna do our circuit testing at. One thing to note on this actuator is when you're unplugging it, you want to make sure this gray tab here gets lifted up. It should lift up about 1/8 of an inch, and then you'll be able to unplug it. If not, you'll end up breaking the plug. Alright, so first thing we're going to do is we're going to go ahead and do some circuit verification, or whatever you want to call it. Basically, we're going to see which pins do what. So this connector has slots for 4 pins, and only 3 of them are used. Another thing to note, always make sure you use some flex probe adapters, that way you're not damaging the plug. With it being a 3-wire actuator, that means it's controlled by pulse width modulation. So you're going to have power, ground, and then you're going to have a signal power from the ECM. If it were 4 wires, then it would be controlled over the CAN network. You'd have power, ground, and CAN high and CAN low. Right now on these outer 2 pins, we've got a little under 12.5 volts, and you know which one's going to be power and which one's negative by the meter itself. With it reading 12.48, we know that the red lead here on the left is going to be the positive side and the black is going to be the negative side. A good way to test that is to go ahead and switch them around like we have here, and as you can see, the meter is now reading negative. So we know for a fact that that pin on the right side is going to be our ground. Alright, next thing we're going to do is we're going to go ahead and load test that power and ground. This is going to be the same as using a test light with the prong on it and the clip for the ground, only this time I've made my own. I've got a taillight socket, and I've got them adapted to these banana jacks, that way I can plug it directly into my meter, and we are going to feed off of the power and ground that's provided to this actuator. So I'm going to go ahead and plug this in, and first thing we're going to look for is see and make sure we have a good light, and with it plugged in tandem with the meter like this, we can also check the voltage drop across the circuit. Alright, so I went ahead and got that red lead plugged in, and as you can see, we've got a nice bright light here, so that means this circuit can hold a load and support it. And with the voltage drop, before we were reading 12.52, and now we're reading 12.2827, somewhere in that ballpark, so we are well within range. Typically, you don't want to see anything more than 1/2 volt drop across the circuit. If you see any more than 1/2 volt, you've got resistance somewhere more than likely, or a bad connection. Next thing we did, I went ahead and moved the lead, positive lead, over to the signal line, and I kept our ground because we know it's good. And we've got a little over 2 volts here, 2.32. So that right there is just telling us that the computer is sending voltage to this light, and it's important to note that I went ahead and removed the load from this, because if you put a load of your own on a pulse width modulated circuit, you can short out the drivers in the module. So that tells us that the computer is attempting to send signal out. Next thing we're going to do, we've already load tested the power and ground for this circuit. Now what I want to do is load test the signal line. So we're going to keep it unplugged here, and we're going to unplug the other side of the harness at the MCM, which is the ECM for this engine, and we're going to run it in line with a light, and we're going to make sure that it can hold a load. All right, so 1 lead of my multimeter, I have it hooked up to the signal line on the turbo actuator, right at the plug that plugs into the actuator, and then on the other side here, on the MCM, which is the main, I guess, module for the engine. I was just probing each pin until I found continuity to that wire, which I believe was pin 35. Alright, so we've load tested the power and ground going to the actuator. We've load tested the circuit going from the actuator to the ECM for the signal wire, and we know that the ECM is sending out voltage to control the actuator. So, being that the code is still active, that leaves only one thing, and that is the actuator itself. Somewhere in there, we've got an opening, so we're gonna go ahead and replace that. All right, just got a hold of the new actuator here from Freightliner, and a couple things to note. Number one, this plug here, this banjo bolt and this air fitting do not come with the new one, so you're either going to have to swap them over from the old one before you turn the core back in, or you're going to have to get new ones. And there's 2 crush washers on this banjo fitting here, 1 and 2 you can see there, and then there's 1 on this plug here. So you're going to need 3 crush washers, which you can also get from Freightliner, and each of these fittings, the plug, banjo bolt, and the air fitting, take a 17mm wrench. And the 2 bolts that hold the actuator to the motor are both 13mm heads. All right, got this thing back from a test drive, and the code for the turbo actuator went away, fortunately, so we know we did our diag there right, but the code for the turbo speed sensor did not go away. So now we're gonna test that out. It's a pretty simple circuit. It's a 2-wire sensor. We got the plug right down here with the green wire. We got the plug there. That goes to the MCM or the ECM, whichever you want to call it. So we're going to test the wiring to it and go from there. All right, so to test the ground wire on the speed sensor line, we're robbing power from the actuator harness there, and we're going to run a test light through it. And as you can see, sitting idle, we have 12.83, and test light lights up good, and we only drop down to 12.58. All right, so back onto the truck here, we got the MCM up there, and what I did is I ran a wire from the power side of that sensor into my meter, which is hanging there, and it's got the audible tone feature, so when it detects continuity, it'll start beeping. And I ran the other side into the adapter probe, and I just probed along until I heard the beep. So I know I got the right wire. Alright, so I've got 12 volts ran from the battery over to the ECM here, into that pin that I showed you from the bottom. You can see the adapter probe where it goes into the plug there. And if I can get it to focus, yep, there you go, you can see the adapter probe there. And that wire is going into the ECM side of the signal wire for that sensor. And on this side, we've got the sensor unplugged, and we've got a flex probe on the power side of that harness, and it's coming up here to the meter, and we've got a ground hooked to that stud there, and as you can see, we've got 12.92, and we'll go ahead and hook the ground up from this light bulb, and the light bulb comes up nice, and we only drop to 12.64, so we're still within that half volt drop range. Alright, we went ahead and got the turbo speed sensor replaced, and we've got the computer hooked up, and we're going to go ahead and give it some gas and make sure that the turbo speed sensor reads properly. Wide open throttle, we're pushing just shy of 80,000 RPM. The sensor's following just fine, so I'd say we're good to go. We're going to test drive it, make sure the code doesn't come back, and send it back to the customer. Alright, so just a little recap here, and you guys are going to be subject to my artwork, so enjoy it.
We've got the ECM, or the MCM as Freightliner calls it. This is going to be controlling everything engine related. We've got the actuator here, and we've got the speed sensor. So the code we had for the actuator was only saying that the ECM saw that there was some sort of opening in the wiring or the actuator itself. Somewhere from here to here, there was an opening. The code for the speed sensor was saying that the reading the ECM was getting was too high and out of range for what it should be getting. So the first thing we did for the actuator was go ahead and load test the circuit. Doing the power and ground was very easy. You've got positive here, negative here. We hooked up our test light, and as long as we have a load on it and it stays consistent, we know that our positive, the red wire here, and the negative, the black one, are good, and we don't have to worry about anything with them. Load testing the signal wire is a bit more complicated. So we can see that we had, I believe it was 2 volts or something like that at the signal wire at the actuator. Now that does tell us that the ECM is sending out voltage, but unless we know exactly what voltage the ECM is sending out, we don't know if it's getting the job done. The ECM could be sending out 8 volts to control the actuator, and we only see 2 there. There could be resistance between here and here, and just because we see voltage doesn't mean that that circuit's good. So with the plug disconnected at the actuator and the plug disconnected at the TCM, we went ahead and got power from the battery and ran it straight to this pin here, which was going to send power to this plug at the actuator. And then over here, we went ahead and put the test light and the end of it and grounded it. And we saw that the light was showing up good, and we didn't have anything over a 0.5 volt drop across the circuit, so we know that that wire was good. It's important to note that every time I use a flex probe adapter, I'm also checking pin fitment at these plugs. So you want to make sure that you've got good drag on the pin, because if the pins are spread too far out, you're not going to make a good connection and you'll see intermittent problems. For the speed sensor, we had a signal line coming out of the ECM and a ground going back to the ECM, or signal return, whichever way you want to put it. So with this wire being nothing but a signal wire going to this speed sensor, it's a very low amperage circuit. So with that being said, it is way too low of amperage to be powering a test light. So if I were to plug a test light into there, we would see the voltage drop, and there's a chance that I would damage the ECM. So we didn't do that. Instead, we did the same thing that we did on the signal wire going to the actuator. We unplugged the speed sensor and unplugged the ECM and ran power to the signal wire and put a test light on the other side of it. That way we're only worrying about the wiring, and we also saw less than 0.5 volt drop there, so we knew the signal wire was perfectly fine. For the ground wire, that was pretty easy. What we did was we tapped into power over here at the actuator plug, and I should specify that it doesn't matter where the power came from. We could have gotten it from the battery or anywhere else, or even from the alternator stud. This one was just most readily available. So we robbed power from there, put a test light on one side of it, and then we grounded the test light on the ground wire going back to the ECM. And the test light went up, and we saw less than a 0.5 volt drop. So with that being said, again, we ruled out the pin fitment, ruled out the wiring. Only thing left was the speed sensor.